Okay, so lesson 19 is solving systems of inequalities. So your learning objective, which I didn't write down because I wasn't thinking about it because I'm not in my notebook, but I can solve systems of inequalities. Okay, so basically what we're doing is we're just graphing inequalities and then finding where their shaded regions overlap. When we were doing I'm sorry, I'm stumbling over my words today. When we were talking about systems of equations and solving them, we said that the solution was the place where they intersect. Okay, so that one intersection point was the solution. However, when we're talking about inequalities, when we graph those on a coordinate plane, we shade a big portion of the graph. Okay, so we're no longer looking for that one intersection point. We're looking at where those solutions overlap, where those shaded regions overlap, and that is where you can find all of your different solutions to the inequalities. So today we're going to look at graphing some inequalities. In your Math Excel work, most of them are multiple choice. So you're not going to have to do a lot of the actual graphing using those graphing tools. You'll just have to look at the graphs and see which ones are correct, which ones match what you should have. However, you do have a couple problems at the end where you're actually going to have to use the graphing tools to graph the systems. So we'll just go through that here on these examples. This is review for you for the most part. So we'll just look at what the graph should look like. We'll talk about the different kinds of lines and go from there. Okay. So number one, we're given y is less than or equal to negative 4x minus 4. So I'm going to use this green color to graph that line. Okay, so my y-intercept is negative 4, so I'm going to put a point at negative 4. My slope is negative 4, and I can put that over 1. So I'm going to go down 4 and over 1. I'm also going to do the opposite. So I'm going to go up 4 and left 1. And I'm just doing that so I can make a nice straight line. Okay, that's the only reason I'm doing multiple dots. Now, I look at this inequality symbol. It is equal to, so that means it's going to be a solid line. So I'm just going to make a normal line. And it's less than, so I'm going to shade below. So this is the side where the y values are less than that line. Okay, I'm going to do the same thing with the second equation, except I'm going to use blue. I just happened to pick up North Laurel colors. Sorry about that. Just go with it. We have a y-intercept of 2, and then my slope is 1. So that's 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. And I'm going to keep doing that for a few. Again, I have an equal to, so it's going to be a regular line. And this time I'm shading above. It's greater than. So I'm going to shade that region above the line. And as you can see, we have a section where those colors overlap. So this is where our solutions can be found. So our solutions are any coordinate point in that overlapped region. Now, in your multiple choice questions, it might not show you these two portions that are colored with one color. It may just have this overlapping section shaded in. So you are going to have to look and think about where each line should be shaded. Okay, and if you need to do like a little sketch on your own paper, you're welcome to do that. Because you could just sketch out what you think the line should look like and then shade, and you should still be able to see the overlapping region. Sorry about that. I had a phone call. So like I was saying, even if you just sketch out the lines on your paper and color in where they should be shaded, you should still be able to see that overlapping region and pick the correct answer in the multiple choice questions. Okay. All right. So number 2, we're going to do the same thing. So I'm going to use green for this first one. So my y-intercept is 2, and my slope is 2 over 1. All right, I have less than or equal to, so that is a solid line. And I need to shade below. All right, now this next equation, you can do it a couple different ways. You're going to get fractions either way, but if you want to do the y-intercept, x and y-intercepts, where you cover up this one, get negative 6x is greater than 14. You can divide and solve it that way, or you can solve it for y. I would probably solve it for y if I was doing it just myself. So I would add 6x to both sides and have 3y is greater than 14 plus 6x. I would divide everything by 3 and get y is greater than, and I should have actually turned it around, 2x, and then plus 14 divided by 3. I'm going to do the decimal here. I know we normally don't do a decimal, but just to get the approximation on a graph, I think it's a little bit easier to think of it as decimal. So that's 4.7-ish, okay, rounded. All right, so our y-intercept is 4.7-ish, so that's almost 5. And our slope is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1. And it's greater than, so that is a dotted or dashed line. And it's above, so I'm going to shade above that line. Okay, and so what you should notice here is we had the same slope, okay, and when we get those on the graph, we don't have an overlapping shaded region. The green is below, the blue is above, they do not intersect. So that's really a no solution because your shaded regions do not overlap. Okay, number 3 is a little bit different. We have a linear inequality and an absolute value inequality. So we'll just do one at a time. So I'm going to do the top one with the green. So my y-intercept is 3. I don't have an x, so my slope is 0. So I'm just going to go straight across. Okay, it's greater than, so that is going to be a dashed line or dotted, whatever you want to call it. And it's greater than, so I shade above. Okay, now, this is my absolute value inequality. So remember, the number on the inside, you're moving left or right. So negative is right 2. So I'm going to go over 2 from the origin. And then our absolute value is that V shape. You just go up 1, over 1, up 1, over 1 on both sides to make that V shape. It's less than, so it is going to be dotted or dashed. And we're shading below. So everywhere below that absolute value. And so you see here we have 2 shaded regions where the colors are overlapping. So your solutions would be found in these areas. Okay. Last example, number 4. We're doing the same thing except we have 3 different lines. And that's okay. We're still going to do them the exact same way. All right. So we have negative 2x minus y is greater than or equal to 4. You can do your intercepts or you can rearrange it to y equals. I think that's what I'm going to do here. So we'll add 2x to both sides and get negative y is greater than or equal to 2x plus 4. Then divide everything by negative 1. So that's y is less than or equal to negative 2x minus 4. Okay. And so my y-intercept is at negative 4. and my slope is -2, so down 2 over 1, down 2 over 1. I'll go backwards a couple. All right, that's less than or equal to, so that is a solid line. And I'm going to shade below. Okay. My next line is y is greater than or equal to -6, so I'm going to go to -6. And my slope is 0, so I'm just going to go straight across because it will be horizontal. It's greater than or equal to, so it is a solid line. And we're shading above. Okay, and then our last one I'm just going to do with this pen color. It's x is greater than or equal to -2, so I'm going to go to -2 on the x. It's a vertical line, so I'm just going to go up and down. It's greater than or equal to, so it is solid. Okay, and greater than is to the right. So on this one, you'll see the shaded region is this little triangle at the bottom. That's the only place where all three colors overlap. All right, so that one's a little bit different. We're doing a few different lines, but you're following the same process. Okay, now the only other type of problem that you'll see in this homework are ones where they say, is blank a solution to the system? So it'll say, like, is 5,2 a solution? And so what you would do is you would find that point on the graph and see if it's in that overlapping shaded region. So for example, if I asked you, is 5,2 a solution to this system? We would go to 5,2. Is it in the shaded region? No. Okay, what about, is -8,3 in a solution? So we'd go to -8,3. Is that in the overlapping region? Yes. So that would be a solution. So you have at least one problem like that, maybe a couple, but they're pretty self-explanatory, and I think you guys will do just fine. So like I said, on some of these, you're going to have to graph it with the graphing tools. Others, you're just going to have to look at the multiple choice graphs and choose the one that should match. Okay. As always, if you have questions or need help, please let me know. Hit the Ask My Instructor button, send me an email, whatever you need to do. Have a great rest of the day.